Alright, so for problem 8, we have Wile E. Coyote is holding an Acme anvil, and if you've ever watched the old Looney Tunes, very familiar with the situation. He's holding the anvil on a cliff that is 40 meters high. The Roadrunner, who is 1 meter tall, we are going to use that, is running on a road towards the cliff at a constant velocity of 10 meters per second. Wile E. Coyote wants to drop the anvil on the Roadrunner's head. How far away should the Roadrunner be when Wile E. drops the anvil? So, like with before, we're going to have same sort of situation where we're going to have our cliff. But what's going to be different about this one is this is going to just go straight down. We are going to have still an initial height and a final height and such, and we're going to have an initial speed. I'm not going to worry so much about the final speed on this one, again, because the equations we're using aren't accounting for that. And what's different is now we've got the Roadrunner. Here's my Roadrunner. That's going to be a super bad Roadrunner. Okay, he's running this way at a constant velocity. So I'm going to call this velocity of Roadrunner of 10 meters per second. It actually will be very similar still to what we've done before. What we are going to have happen, though, is our equations are going to feel a little different. First of all, when I look at Wile E., his equation is 100% in the y direction. Let's just rewrite that because it's getting a little bit sloppy. YF equals YI plus VIYT plus 1/2 AYT squared. When I look at the Roadrunner, his is in the x direction. XI plus VIXT plus 1/2 AX T squared. Alright, so right off the bat though with the Roadrunner, I'm going to take care of a couple things. He's going at a constant velocity. That means there is no acceleration, remember. Acceleration is when you're changing velocity. And also, we're not going to worry about his initial speed. We're going to say just like where he's at right now, that's going to be his initial. But where he lands here, that will be his final, which we will need to figure out. Again, it's how far away should he be. I'm going to use that as the place that I'm looking for. I could also change the order. I could call XF0, XI, therefore would be my question mark. But this is how I'm going to do it. I know that this is going to be my initial velocity in the x direction. I don't know how much time it's going to take for him to get there, though. So time is an unknown. Now, to look back at Wile E's situation, the cliff is 40 meters high. So let's say that he's starting at 40 meters. And when he falls, he doesn't actually have to hit the ground. He's trying to hit the Roadrunner's head. And the Roadrunner's a meter tall, so this is actually going to be 1 meter here. It's going to be a situation where I'm not going to be canceling out one of them. But I do want to make a note that because I've got 1 here, 40 here, just think about your number lines. That means that this direction you're up is your positive direction. And the way I drew it too. Now I've switched my order for my X. Alright, so I've put in these two values. Let's see, my VIX, like I said, because he's all in the Y direction, I actually want to focus on my VIY here. Because he is dropping it, right there, we can assume that this will be 0 meters per second. Remember, anytime you drop it, you're not giving it initial speed. So we think about what happens if we turn gravity off. So that takes care of this one. Again, I don't know time. And of course I do know my acceleration in the y direction, because it is your 9.8. And I double check against my positive direction here. Because up is positive, this will be a negative 9.8. Bad negative, but that's a negative. Okay, once I'm to this point, now I can plug in my numbers. Again, this problem, not necessarily that it's that difficult, but it's different than the rest of them that I gave you, which is why I kind of wanted to do this one for you. So, I start plugging in my numbers. 1 equals 40 plus, let's see, this was 0, so I might as well just go ahead and cancel that all out. And then 1/2 negative 9.8 t squared. And xf, let's see, that one was a question mark as well. That will be 10 meters per second times this unknown time. And there we go. So, let me make sure I've got a calculator pulled up here on my other screen so that I can do the calculations on this one. I'm going to subtract 40, I get negative 39 is equal to 1/2 times negative 9.8 is negative 4.9 t squared. I'm going to divide by negative 4.9, divide by negative 4.9, and I get t squared is equal to, let's see, negative 39 divided by negative 4.9, I'm getting 7.959. I'm going to take the square root of that. Let me give myself a little more space. And I get that the time will take less than a second. Wait, nope, sorry, I put a decimal in the wrong place. It's going to take almost 3 seconds. .82 seconds. Once I have that number, I plug it in for the time down here, because they are, of course, the same time. And I get xf equals 10 times 2.82, which gives me 28.2 meters. So, in other words, Wile E. Coyote, and this is going to be one of the hardest things to eyeball, but he wants to watch for when the Roadrunner is 28.2 meters away from where the anvil is going to drop. And he should be able to hit the Roadrunner on the head. If you have questions on that one, let me know. I do want that one in your homework, so make sure you copy down the work, copy down the picture, and of course get the answers. And turn it in with the rest of your homework.